Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And I've got Tony VK7XTC with a spectacularly good Teeshirt on. Pink Floyd, Dark Side of the Moon. Hello, Tony.
How you going?
Very well, yourself?
Not bad.
Excellent, excellent, thank you. Wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and the hopes of Aboriginal Tasmania. Now, the reason I have Tony in the studio tonight, and hello to Paul Pruss, and hello Andy, all the way from the UK. Now, oh, very good, very good. Tony, over the last couple of weeks, has been posting to our Discord channels the progress he's been making on his very nice valve guitar amplifier. So I thought what I would do was get Tony in to take us through a few things about the amplifier. And probably the first thing is, why did you build it?
Well, this is the second one. The first one I built just on a sheet of aluminium.
Okay.
Just as an exercise, working with valves and
Okay.
high voltage and to learn something.
Okay.
And the practice.
Cool.
Had that for about 6 years, 7 years, like that.
Okay.
It worked okay. It was just untidy.
And probably vaguely
And
dangerous.
it wasn't very, it wasn't very safe. If you put your fingers around the side, you could have gotten shocked or whatever.
Okay.
So I've been saving bits and pieces up over the years. I saved up for the case, the chassis, and other bits and pieces.
So did you have did you make the chassis?
No,
or
buy that from evacto.com.
Oh, okay.
They sell all amplifier gear home to build yourself. So you can buy turret boards for the different makes of and different chassis of amplifiers, and you just wire it up point to point.
Yeah, yeah.
You can buy all the bits and pieces. So,
and this is an American company?
No, it's in Australia, in Melbourne.
There you go.
Yeah.
I love it.
So this time I wanted to build it properly, neatly, and have the layout correct.
Okay.
Because last time I had my power transformer in my preamp, and I was picking up hum and all that sort of stuff, but I didn't know what I was doing. So this time I wanted to lay it out correctly, and
there you go.
And that's it.
So now you build other things which plug into this amplifier, don't you?
Cigar box guitars, yeah.
So tell us about cigar box guitars. They obviously have a cigar box as the.
Yeah, it's in there, but I haven't brought it in here with me.
No, that's all right. That's the next program.
Yeah. My dad showed me a video once on Facebook.
Okay.
About 10 years ago, of this guy who builds them in America called Rooster Run Workshop or something.
Okay.
Anyway, I thought, wow, that sounds so cool, the sound of it, and it was really bluesy.
Yep.
And I wanted to learn another instrument because I played clarinet when I was a teenager and young adult in a concert band. So I wanted to learn the guitar. So I thought, I wonder how much one of these are to buy. And they were about $400. And I thought, I can't really justify that because I was in a relationship and all that. So I thought, I wonder if I could make one. So I had a go at it. The first 3 didn't work.
Okay.
The intonation was wrong. They sounded horrible. They bowed.
Right.
And then after the 4th one, I got it all figured out. And now I'm up to my 11th one. And the one that I have inside is number 9, which I kept for myself. And all the other ones I sold.
You sold all the others. Yeah, okay.
Sold them at a market.
Okay.
Yeah.
Wow.
So it was just, I always like to try and see if I can build it myself.
Yeah.
Everything.
Yep. Yeah.
Homebrew. I love homebrew. So.
Well, there you go. Fantastic.
So yeah, just in my little shed, and I'll have a go at anything.
Well, let's have a closer look. So the design you have used.
The design is on the PA section. It's Fender.
Okay.
On the preamp side, start again. The phase inverter and the tremolo to the PA is Fender.
Okay.
And the preamp is Marshall.
Oh my goodness! You're mixing and matching Marshall and Fender.
Yeah, well, I like the Marshall tone stack.
Okay.
So it's got the 3 controls: the bass, treble, and the mid.
Okay.
Whereas Fender usually just has a single tone control or just treble and bass.
Yeah. Okay.
Yeah.
So it gives you a bit more differentiation.
Yeah. And then you've got the bright switch, which brings up more treble again.
Okay.
Especially on low volume.
Okay. And what's the other switch for?
Negative feedback. You can switch it in or out.
Okay.
So you can, if you switch it out, you can increase the gain a bit and bring in some distortion.
Okay.
So, and if you flick the negative feedback in, it'll give you more headroom. The gain will drop a bit, but it'll stay clean.
Yeah.
As you turn it up.
Okay.
For longer. But yeah.
Okay. And what are the depth and frequency?
Depth and frequency is a tremolo.
Okay.
So there's I'm only using 1/2 of a 12AX7.
Okay.
The triode, 1/2 of it, as the oscillator.
Okay. Yep.
So you can adjust the depth, so the intensity, how strong the tremolo is.
How far it goes into it and out.
And it's a grid bias tremolo.
Okay.
And the frequency, so you can adjust the speed.
So that's in a quite a low, like an audio level oscillator.
You're actually changing the volume of the output.
Okay.
By adjusting the grid bias, making it go in and out.
Okay.
So,
Okay. I think I understand that well and truly.
Yeah.
And that's a Fender design, or is that a Marshall design?
That's a Fender one. The Marshall one usually uses both sides of both triodes.
Okay.
On their tremolo circuit, but I only use one.
Okay.
To make the oscillator.
So the output stage of this, take us through what's giving you the audio power?
6V6s.
So that's those big valves.
Those two
yes.
there. Yep. That's it. They're in push pull. So they're at their plate dissipation of 14 watts each.
Okay.
And they're biased for 70%.
Okay.
Which is a safe threshold, so you don't
cook
them. And with the tilt in push pull, they claim you can get about 15 to 20 watts output.
Okay.
So some guys reckon they get a bit more, but I'll have to do a test with the oscilloscope and the dummy load.
Yeah.
And work it out mathematically to see what's going out.
We'll get you a dummy load.
Yeah.
So if we can turn it round and show now, Tony's done a spectacular job, and I just point out the yellow filament wires that you can see closest, which are these.
It's a heater wiring.
Yeah. I couldn't believe it. I suddenly realised that this is actually waxed canvas covered wire, but it's new. It's new.
It's new, brand new.
It's new.
Yeah.
So it looks quite old, but it's brand spanking new waxed canvas covered wire. Just off the show. And power transformer.
That was just gifted to me years ago, so
okay.
It's just I really don't know where it's from or what it is, but it's.
And you were saying
320 volts, 325 volts AC.
A side? Yep. Okay.
And it's got a winding. It's got a heater winding for the rectifier valve, and it's got two windings, two 6.3 volt windings for the heater.
Filaments, yeah.
And they're paralleled.
Okay.
Because all the heaters and the indicator pilot light.
Yep.
They draw 1.9 amps.
Okay.
And the winding's only rated for 2.
Right.
So I've paralleled the two amp windings.
Fantastic.
For that, and they've got a virtual center tap.
Yep.
200 ohm, 1 ohm resistors to ground.
Okay.
So that balances out the two windings, any differences.
Yep.
And gets rid of the hum.
Okay. There you go.
So,
and you've got a slightly modern filter.
The line filter.
Mains filter.
Yeah, that's out of a CRT. An old computer monitor. It's just recycled.
Okay.
Just
turn it around a bit. Yeah. Point.
Oh yeah, down here. Yeah.
So that's the filter.
That's the line filter.
Down the bottom.
Yeah. And it's got the choke, which is there. That's recycled out of a TV.
Okay.
There's nothing wrong with it.
Oh no.
I think it's about a 1k ohm resistance.
Okay.
Yep. And then you got the filter board.
Yep.
For the high tension.
And what's the transformer in the middle?
That's the output transformer.
Right.
That one there.
Okay.
Yeah.
Okay.
So the power transformer's lined up this way, and the output transformer's the opposite, 90 degrees.
Yep. So minimising the coupling.
Interaction, yeah.
Yeah. Okay. Fantastic.
Yeah, and that's about it. I can't say much else actually.
And just the any comment about the dangers of valve design and operation?
Well, every time you turn it off to work on it, you've got to check your filter caps.
Yep.
To make sure they're discharged. And if you've got your valves in and you switch it off because they're hot, they'll discharge.
Yeah.
But if you don't have your valves in, those filter caps will stay charged for hours.
Yep.
And so you put one hand in your pocket and only one hand inside it. You don't touch any metal or anything like that. But, yeah.
Yes. Yeah. Okay.
So you constantly got to think about it.
Okay.
But yeah, otherwise it's safe. It's
Oh, well, it was the technology of the time. So hey.
And it's grounded inside. The chassis is grounded to the main earth.
Yes.
And so it's a transformer common.
Yep.
And the shield.
Yep.
It's all back to the 1 point.
So there is a shield in that transformer.
There's a shield in that transformer.
Yeah, okay.
Yep, to separate the two halves.
Yeah. Okay.
Yeah, and then all the ground from the preamp all comes back to 1 point to the filter board.
Yeah. Okay.
So you don't get any ground loops.
So you've got it in a star arrangement. One point.
It all comes to 1 point.
Yeah.
Yeah.
Okay. Okay.
Yep. Star ground.
Now, the $64,000 question here, Tony, is how does it sound?
It sounds all right. I'll give a demo outside there.
Okay.
Later, but yeah,
Okay.
Yeah.
Okay. All right. So, fantastic. Now, hang on. We've got Bronson the Cat asks, does it go to 11? You can demonstrate that.
Oh, yes, it does.
It does go to 11. It does go to 11. There you go.
Okay, the dial shows 10.
Yep.
But
it goes one past.
It goes 1 past 10.
So there you go, Bronson.
It does go to 11.
I love it. Absolutely love it. And we've got Lionel, KJ70FH, who's awake in the wee small hours. And we've got Warren. We've got Warren and David Bannister as well. And we've got Warren from Ferny Creek, Mount Dandenong. Oh my goodness, Warren's in VK3. So there you go. Good stuff. So that is fantastic, Tony. Full credit to yourself. It is absolutely brilliantly put together.
Yeah, I like to share what I'm doing in the shed because I think on our Discord channel, I think some of us could probably share some more of what we're doing in our workshops.
Well and truly.
Because that's the whole idea of the club is radio and electronics.
Yep.
So.
And there are lots of home brewers out there who are
closet home brewers.
Closet home brewers. And we want to see more. We want to see more on the Discord channel.
It doesn't matter what it is, just whatever you're doing radio wise in your workshop.
Yeah.
You know.
Or electronics wise, or whatever. So, well, there you go. It made my night. Bronson the Cat made my night. Nigel Tufnell would approve.
Oh, okay, cool.
So there you go. So. Fantastic.
Awesome. I'm glad. Yeah.
Well,
right.
We'll get you back in the studio in a fortnight's time because it's presentation night next week.
Yeah.
And we'll get you to go through the cigar box guitar.
Okay. I'll bring it back in.
Guitar box, and we need to actually hear it.
Okay.
Through the amplifier.
I'll do a bit of practice.
Even just smoke on the water. I'm just a few chords.
Oh, I can do a bit of Wish You Were Here.
Oh, now, good question, Warren. How many watts?
Just as an estimate, I reckon it's between 15 and 20.
Yeah, okay.
I'll have to measure it, which I haven't done yet.
Okay.
But I do know how, just putting on the scope and measuring peak to peak before it starts to square off.
Yeah,
or triangulate.
Okay.
So you get a nice clean sine wave and then, work it out with the Ohm's law.
That beautiful,
so
warm...
I can actually work exactly what it is, what the output is.
Yep.
So.
Yeah. Yep. That
and
warm Fender sound.
Yeah. So I'll wait till you finish your broadcast and then we'll plug it in and...
Fantastic.
Yeah. All right.
That is fantastic. Thank you very much, Tony, for bringing that in. Love it. I think Tony said about 14.
Yeah,
Yes.
15 to 20, yeah.
Yeah, 15 to 20. So there we go.
Yeah, cool.
No problem. Thanks, Warren. And thank you, Tony.
No worries, anytime.
That is fantastic. We'll do a bit of a reset of the studio, and we are finally getting to this device. After many tasters, I expect Van Halen's Eruption from Bronson the Cat. So there you go. So...
yeah, no worries. I'll put a Bluetooth unit in it and
I love it.
Play it off my phone.
And then make it look like you're playing it. Doing a bit of air guitar.
Yeah.
I love it. Good stuff.
The guitar is just something to do.
Yeah.
Yeah, that's all it is.
Okay.
It probably won't get very far with it, but yeah, it keeps the brain ticking over.
And can I just say, there is a very, very ingenious speaker, which houses a very nice Fender. What size?
12 inch.
12 inch.
50 watt speaker.
50 watt speaker in a
wash tub.
So we'll show that as well in a couple of weeks' time. So there you go. Fantastic.
Okay, cool. No worries.
Thank you, Tony.
Thank you.
Love your work. Absolutely love your work. And while Tony's, I'll just show off the new T-shirt. So this is a T-shirt that is every ham needs. And apologies to Fatboy Slim. So we have I have been giving you tasters all the time around this particular device here. Now let me zoom in a bit here and we'll switch it on and get the display around the right way. Now, what are we looking at? we're looking at a this device is a RadiaCode 103, and the RadiaCode 103 is a radiation detection, dosimeter and spectrometer, all built into one device. It is obviously portable. It has a LiPo battery in it. There is a USB-C port in the end of it that you charge the charge it up. You can see there is a little green light that's flashing there. That is the detector. That is the scintillation detector. It is a scintillation device. So what is built into here is a detector that is on the end of a so it's a radiation source inside here, a safe radiation source that has a photomultiplier tube on it, and when radiation hits that particular radiation source, you get photons emitted depending on how strong the radiation is, and that then is detected by a photomultiplier, which is in here, and it then reads, obviously there's a computer in here that then reads both the count, which is what you're seeing on the green light, but it also is adding to the dose rate, and I'll go through that in a minute. It's adding to the dose rate. It is, one of the things about it is, and one of the key selling points, I suppose, for this particular radiation monitor is it is ultra fast at detecting radiation, and so it can actually detect and process both the level, and if I zoom in here, you'll be able to see and here's the display. It is the background radiation, which it's detecting right at the moment, is 0.08 microsieverts per hour. It's vaguely accurate. It's giving you that accuracy. The speaker is on, so it is clicking away. And this is there's a scale down the side, which is the level. There's a battery detector, etc., and a time and a temperature, because the detector is temperature sensitive. You can go through and change this. If we go to the monitor, let me go to the dose. So if we go to the dose, this is the dosimeter. So this is the amount of radiation that it has detected. You'll notice that it says it has been 5 hours and 53 minutes. That's the time that it has been detecting radiation, and over that 5 hours and 53 minutes, it has detected 0.88 microsieverts of radiation that it has received. And so this is a dosimeter is something that you would wear if you were in a radioactive or an ionizing radiation environment. It would detect the dose that you get and record it. If you're working in a facility like a nuclear power plant or the ANSTO facility at Lucas Heights, you would be wearing one of these all the time that you're in that facility, so that they can make sure that you're not getting overdosed with radiation. The other thing, I'll just show you the other settings that are available here. There is the monitor, which was what we had it on, and spectrum. Now this gives you the spectrum, so this is the energy spectrum of what it's receiving, and you'll see that there is a bit of a peak just here. I'll go into that in a sec on my phone because there's a lot more detail, but it gives you what it's detecting is the energy level of what it's reading, and you can make an estimate of what that radiation source actually is, so what the isotope that it's actually receiving, and make some estimate of whether it's radium, it's cesium, it's thorium, it's americium, etc., etc., etc. So I'll go into that in a bit more detail in a short while. It has alarms that I'll just go back to the monitor, power off, search, dose, monitor. Okay, so we'll go back to here. I'll show you what happens with the alarms now. Actually, I think what I've done is turned off the sound. Just give me now. Okay. Now let's go down to, because if there's no sound, you're not going to hear it. Now I'll just hold this over by the microphone. You can hear that going off. It matches the obviously matches the clicking, matches the light that's also flashing to give you an idea of what sort of sound. It's like your Geiger Muller tube. It's the same sort of count. It's the number of counts per second, per hour, etc. However you set it up. Now I'll just show you. There sets alarms. Sets the default alarms are, if it goes over 20 counts, 20 counts per per minute, or if it goes over 40 counts per minute, it starts to get up into the scary amounts of radiation. I'll just show you what that looks like on here. You can see it's starting to go up. And you can see it went to red, and there is an alarm that goes off that you need to reset. So you need to push the button. You can see it says there are alarms, so you need to reset it, and you can set the levels that alarm goes off at. I'll go into what I use to set that off in a sec. So hold that thought. Now there's an ability using the application either on a PC, or I have downloaded the smartphone app. So this is the smartphone app. Oh, hang on, let me just. So this has connected via Bluetooth to the device. You can see there is radiation level. There is the dose rate, so it's actually giving me both of these at the same time. There's also some tracking that is available on this, so you can wear this device and get the phone to track via GPS. If we go into the tracking, you can see it's given us the domain. One of the things that I can do here is show you. Oh, hang on, that was the wrong button. Show you. Here we go. Now I've prepared some earlier. So I wore this device in my sock whilst I was walking around Hobart, and you'll notice this is me walking to and from work, and you'll notice there's a bit of a red dot in the middle. So if you zoom into this little red dot, you'll notice that when I went down this little laneway here, which I used to cut through from one road to another, the level of radiation went up, which intrigued me. I didn't know that it had gone up because I'd switched off the alerts and any audible things, because I was wearing it in my sock. My sock was blinking away. So I looked at this and I went, well, the facility that is right next to this laneway is actually Radiology Tasmania. Now, for those who don't know, Radiology Tasmania is is exactly what it says. They do a whole lot of X-rays. They do ultrasounds. They have a MRI machine, and they use nuclear isotopes for their MRI machine and a few of the other machines, where they inject into you so that they can then scan and find out what's happening in different parts of your body. And so this was quite interesting to me. So what I did was, this morning, when I was going down that laneway again, I made it a little bit slower and I actually put this detector right up against their wall all the way down, and you can see it goes from a background level. If we click on this particular button just before I hit the lane, we're at about 4.3. Oh, hang on, I just got rid of that. That wasn't good. We're at about 4.3 now. Let me, there we go. 4.3, 3.96. When we go into the laneway, let's go to the next one. It almost more than doubles. 0.16 microsieverts per hour. Now we're talking about pretty low level. It's not that much above background. But there is sufficient increased radiation levels next to that building. Now, I don't know whether it's because of the building, it's because of things that have, I don't know, gone down drains, or what the story is, or it might be that particular laneway was used for something in the past. But anyway, it shows you. I'll go to this one here. 7.75 counts per second. Oh, damn, I just got rid of it as well. Let me undo that. No, don't do that, Justin. Anyway, you can see. But this just showed me a little bit of a elevated area right next to Radiology Tasmania. Now, I went for another walk. One weekend, a couple of weekends ago. And, oh, come on. It must be that one. Is it that one? Yeah, okay. Now, up in South Hobart, I took this is the rivulet track, and I actually took the little track, the bush track, that goes up to Liverpool Crescent, which is up here. And you'll notice that when I was going through the bushland, there were elevated levels above background. And so all the way up until I got back up onto the Liverpool Crescent, which is up here, as you go upstairs here. But I found that a little bit interesting, just a little bit elevated above all the way through. And this is a dirt track. This is a dirt track that goes up the hill up to Liverpool Crescent. So interesting. But you can use the device to track. You can do all sorts of bits and pieces. So yeah, that's the tracking feature. Now the spectrum feature. This is the cool bit. This is the really cool bit. So let me go into here we go. So reset. So what it does is that resets and takes it back to 0, and then it starts to record and build up, and it's an integration type function, build up what it thinks the background level spectrum, and this is what we're talking about here is energy level. So we've got energy level across here. So this is energy level in kilo electron volts across here from -2 up to 2,839. And then we've got counts per second up here. So let me just get something that is known high source of radiation. And you can hear the alarm going off. And guess what? It suddenly shows that there is a whole lot more things developing here. You can see there is a peak here, and there is also a little peak down here that you can see developing. and you can put it in linear or log mode. Now let's take that away and stop the. I'll go into what was causing that in a sec. Just stop that because it gets painful after a while. Now if I touch the screen, a whole lot of lines appear. Here we go. Now what you are actually going to do here is we'll just pull this scale out a bit. Now these are decay sequences for different types of isotopes. And what you're doing is you're trying to find the sequence that matches each of these peaks that you're seeing, and then you go up to the top, and I don't know whether this one, let me just try and find a better match for these peaks. That's not it. No. My fat fingers here. No, that doesn't look like it either. Ooh, we're getting close to that. I think that's I131. That's iodine 131, I think. Which has a particular energy signature, and there's no chain, which is that's not right. Let me try. I'm just trying to find a match here. Ooh. Americesium 228, which is goes to thorium 232, maybe. I'd sort of be expecting it more like radium, or at least something that, yeah, lead. Oh yeah, okay, that matches the peaks. That's lead 210, which decays to radium 226. So you try and find and match the decay sequence to the peaks that you're seeing in your spectrum. But this is, can I just say, this would usually be some sort of spectrometer that gives you this sort of energy level, would be a very expensive device normally, and it would certainly not be a handheld type device. So this is outstanding in a device that is not that expensive if you're into radiation and measuring radiation. So yeah, it's it is just fascinating. It's a detector, a dosimeter, and it's also a spectrometer. Now, the device that I generated that alarm with, I'll show you. This is the interesting bit. Is a 1942 compass, and this pointer here and the pointer on here, the pointer's on the end of the compass, and also the pointer that points north, is painted with radium. And just to prove it, it's pretty low level, but it's high enough to trigger the, you're up in the 7 microsieverts per hour. So, so this is painted with radium, which is what they put on dials. It glows in the dark. And if you know about the story of the Radium girls, a very sad story actually during the war, with the women that painted the dials, and unfortunately, to get the really fine lines on the dials and the meters, they used to put the brush in their mouth and get the edge on the brush, and then dip it in radium, and then paint the radium, and then do it again. And a lot of them died pretty excruciating excruciating deaths through radiation poisoning by ingesting radium. So the Radium Girls. Now the other thing, I mentioned, I gave a bit of a view of this last I think last week. These are gas mantles. Now anybody who's had gone camping and had a gas lamp, these are the mantles that go over the gas lamp. They are cotton. They come as cotton, and they are cotton cotton envelopes that you tie onto the gas lamp. In fact, I probably should have brought a gas lamp with me, and you tie them onto the cotton, and then you start the gas up, and you very tentatively raise the glass up and put the match in there, and it goes poof, and suddenly you've got this mantle glowing white hot and giving out light. Now, to enable you to do that and to get it to glow white, these are impregnated with metal oxides in most cases, metal nitrates, so metal salts, and so this is little the cotton's actually impregnated with the metal nitrates. When you light it, basically the cotton burns away, the nitrates become nitrites and become metals, so the everything else disappears, and it becomes basically a metal cage. And that metal cage, once the gas goes through it and it's lit, there's enough energy being supplied that the metals that form that little cage up glow or incandesce, and they glow in the visible spectrum, so it gives off light, not heat, or very little heat. And the problem was, most of these metal nitrates, or the metal salts that these are impregnated with, are thorium salts. And so, just to prove it, not quite as high as the radium, but this is still enough for the alarm to go off. Now the levels here we're talking about are quite low. If you would need to be in the factory making these mantles, and in fact what they use these days is things like yttrium and a few other of the metals to make the salt solutions. And so they don't even go off with the meter anymore. Now, as you do when you buy one of these, you go around your house and you measure all sorts of things, and you find out what's oh, okay, Paul. Oh, we've got thunder and lightning. Oh my goodness! So have to unplug antennas. Be right back. There you go. So as you do when you buy one of these, you walk around your house and you try and find out things that are radioactive. Well, I knew the compass was radioactive because I have a homebrew Geiger counter that I built back in the 80s, and I know that took the Geiger counter off. But the thing I didn't realise was, and just hold that thought, you'll remember this from a couple of episodes ago. This is the Gibson Girl. The lifeboat radio, the American lifeboat radio that we did a bit of a feature on a little while ago. Now, I walked up to this and I went, ooh. The knobs that are on here that have radio and, what's it called? Oh, I can't read it. Hang on. Light. So this is the function switch on the Gibson Girl. These are radium painted dials, so they glow, as well as the knob has radium painted words on the knobs. And so I didn't expect the Gibson Girl to be radioactive as well. So she's hot. She is really hot, as in a manner of speaking. Yes, that was a dad joke. I admit that. But yeah, so and a reasonable amount. We're up to 13, 15 counts, 16.6 counts per minute on that. So she's a hot one. So I just I thought, okay. When you walk around, I did go through, being the geologist that I am, I did go through all my minerals, and I'm sad to say that I did not find any that were any higher than the background level. So so there you go. I'll just go to the dosimeter, dosimeter, dose. Yeah, well, there you go. We are now, we've gone from our 0.88 to 1.01 in the dosimeter. So I need to be a little bit careful because I've just added 0.2 of a microsievert to my dose. Now, can I just say, everyone, you're probably going, well, what dose is safe, what dose is not safe, all of that sort of thing. If we go off to the... okay, sorry, I put that down next to the compass. Which is doing its job. It's doing its job. I went off to the ANSTO website. Now, the ANSTO, for those who don't know, is the Australian Nuclear Science Technology Organisation that sets ionising and non-ionising radiation levels. Now, so we are talking about ionising radiation here, and ionising radiation is radiation that produces particles called ions. So for radioactive objects, they give off free electrons. They have spare electrons, they give them off, and that's what they call an ion. Whereas non-ionising radiation, like our radios, RF is non-ionising radiation. You don't get any extra free particles and all sorts of stuff. So we're talking about ionising radiation here. So alpha, beta, gamma radiation as you go down in wavelength. So average, and they've got a great little video on the ANSTO site. I'll just go to here and zoom out. We've got a bit of thunder activity going on out there. So yeah, things are getting exciting. Now let's zoom in here a little bit. So they've got a great little chart here on the ANSTO site, and I'll post the link in the video description. So 0.03 microsieverts per hour background radiation at sea level, which is the sort of level we get. That's the sort of level that's showing on the radiation meter. 1500 microsieverts per year is the average Australian radiation dose. So over a year you get 1500 microsieverts of radiation just through the background radiation. The average radiation level for a worker is 1750 microsieverts per year, so a little bit higher. The average dose for a crew member of an international airline. So, international airlines, if you're in a plane up above, 37,000 feet or 40,000 feet or whatever, you have much less of the atmosphere that is blocking out some of that harmful radiation. So you get about 4,000 microsieverts per year if you're a crew member on those international flights. Now, the interesting one that I find here is 7,800 microsieverts per year is the average dose in Cornwall, UK. The increased background radiation levels are due to higher levels of radon gas. Absolutely fascinating. And radon gas, the classic thing with radon gas is that it is very heavy, it sinks, it goes into cellars, and if you don't aerate cellars, you can get reasonably high levels of radon gas. Then we go to 20,000 So 20,000 microsieverts per year, the regulated maximum dose for radiation workers in Australia. So these are workers who are in radiation type jobs. This is in ANSTO, in nuclear facilities, etc., within Australia, can get no more than 20,000 microsieverts per year, and they would be wearing dosimeters and telling and that record 24/7. And then 100,000 microsieverts per year, the lowest annual dose with links to increased cancer risk. So when you get up into these sort of levels, you can start to expect some scary things happening. So I just thought I'd share that. Now, lovely view of lightning over Howrah in the airport area. So there you go, off to the east. Are the club rooms safe? Well, probably, yeah. Another dad joke, yes. Okay, Bronson, yes. Keep that radio away from your knob, yes. Love it. Good stuff. So I thought I'd finish off. I have been on a bit of a radiation themed binge watching on various streaming services, and I just thought I'd recommend some interesting watching if you're into those sort of things and would like to catch up on past events that have caused a lot of radiation. Of course, the very first one I'm going to say is Chernobyl. HBO has a wonderful 5-part series that I'm watching right at the moment. There is on Netflix right at the moment a series, about a 6-part series called The Days, which is about the Fukushima Daiichi tsunami event, which is very well put together by the Japanese. And then, of course, there is, and thanks to Sean for this one, on Netflix there is the 3 Mile Island event in the US, which has I think it's a 3 or 4 part series about the issues with 3 Mile Island and the near meltdown, it was a meltdown, that they're still dealing with, a bit like Fukushima and Chernobyl as well. So we don't have equipment that can deal with that sort of stuff at this point in time. All the robots they send in fail after a certain period of time because of the level of radiation. And to give you an idea, we were talking about microsieverts, so millionths of a sievert for background radiation. Fukushima, they were measuring and they calculated. They weren't actually measuring, they calculated, because most of the devices that they took into Fukushima either burnt out or went off scale. And that was the same in Chernobyl. All of the devices that they took into the various areas either burnt out or stuck on full scale. Fukushima, they were talking about sieverts, not microsieverts. They were talking about sieverts, which is pretty scary high levels of radiation. Yeah. Yeah, well, there you go. Watch anything on Mr. Uchi. A major dose was kept alive for 80 odd days. Yes, very sad story. Very sad story indeed. Now, we finish off with our space weather report. There is nil space weather alerts on the Bureau of Meteorology space weather site. So we don't have to worry about anything. Get out there, operate, do your ham radio, eat, sleep, ham radio, repeat. I will post where you can buy the T-shirts in the video description. So next week we have our presentation night. Mars Butfield Addison, who is UTAS PhD student, UTAS / CSIRO, UTAS PhD candidate, is giving us a talk called Space Junk and Amateur Radio. Should be absolutely fascinating. She'll be up here, so we will be streaming that particular presentation. And then on the 3rd of April, we have Peter Picorni, VK2 EMR, who will be giving us a very humorous presentation on the history of UTC, Universal Coordinated Time, and the leap second, and also an update from WRC 23. Peter attended WRC 23, and so he's giving us a bit of an update on that. So that's our show for tonight. I hope you've enjoyed a bit of an eclectic show tonight. We went from valve guitar amplifiers to high sources of radiation. So you can't say we don't cover the things that matter. So this has been VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and we'll catch you in 2 weeks' time, and presentation night next week. 73.